Well, first of all, I want to thank everyone for having me here with the Radio Club of America. I mean, I'm honored to be able to present to you the history of KDKA, to the world's oldest wireless society. I mean, I'm very thrilled. This is the second opportunity we've had to do this. First time was actually in person in Pittsburgh at the studios of KDKA, and then we had a chance to go out to the transmitter site. And I saw that picture that Mike had up of the Westinghouse transmitter, which everyone in the club that was with us that day had an opportunity to see the great facility that we have out in Allison Park. So let me begin by talking about that little plaque that you see in the bottom right-hand corner there of this slide. That is one of 3 Pennsylvania historic markers that talk about KDKA. The world's first commercial radio station, as you could read there. But also there were 2 others. There's one in Wilkinsburg, Pennsylvania, which is dedicated to the location of where Frank Conrad had his original garage and did all of his experimentation with 8XK from about 1915 or 1916 on through to the very night of November 2nd, 1920, when we launched on KDKA. And actually, at that point, we launched on 8ZZ. Frank was back in his garage standing by to make sure that if anything went wrong, that they would bring that first broadcast of the Harding-Cox elections to the public through 8XK instead of on 8ZZ. And the interesting timeline that'll come along here, and I wanted to, before I go on to that, I want to mention the third historic placard that's in Pittsburgh regarding KDKA, and that was where we were on the Saturday before our anniversary date on November 2nd. It's the Hill Station at Forest Park, which Westinghouse, led by Conrad in 1923, had opened up a special facility to work on shortwave transmission and experiment with long distance transmissions to be able to take programming and send it out over high frequency shortwaves and send broadcasts around the world. So that was another notation to the importance of wireless communication and how Pittsburgh is centrically tied into the success story of what we're doing wirelessly for the last 100 years. There is a crystal radio set. That's what they were listening to on November 20th, November 2nd, 1920. But there were also other opportunities for people to listen to that broadcast. In fact, Frank Conrad's wife was a known suffragist at the time. Of course, in 1920, that Harding-Cox presidential election was the first opportunity for women to vote in an election. So, being the suffragette, she organized as many of her friends as they could to get together at local churches, at halls, at places to congregate, corners of the streets in Pittsburgh. And what they did was they took the broadcast of Harding-Cox and played it out over loudspeakers. And over those loudspeakers, hundreds to thousands of people were able to hear that very first broadcast on November 2nd, 1920 of the Harding-Cox election. So what did we start? Let's talk about KDKA first before we start getting into some of the more interesting notions of who was first, who was original, and whatnot. So Westinghouse constructed a transmitter and applied for a government license in October of 1920. Now, the license was listed, and let me just grab my notes here and just make sure I have my dates correct. So 8ZZ was licensed on October 23rd, 1920. KDKA was licensed on October 27th, 1920. Frank Conrad's original license for 8XK goes back to 1916. That night, November 2nd, 1920, 6 p.m. that evening, tiny little makeshift shack atop of the Westinghouse Electric Building in East Pittsburgh. 4 men were in there: engineer William Thomas, telephone line operator John Frazier, R.S. McClellan, who was a standby and who was getting results of what was coming in from the Pittsburgh Post of the election returns, and Leo Rosenberg, who was really radio's first announcer. That was the night that everyone learned through this incredible new medium that Warren Harding beat James Cox in the race for the Oval Office. Of course, KDKA, we can claim many firsts. One of the firsts is the first ever full-time announcer. And there he is right there, that handsome gentleman named Harold ARLIN, who was actually in the Westinghouse publicity department. And they had advertised that they were looking for an announcer to be on this new program, this new project that they were working on at Westinghouse called radio. So Harold ARLIN applied and got the job. And it's amazing some of the firsts that followed with Harold ARLIN. In fact, the first in 1921, he was, as I said, the first full-time announcer. He was also called the first play-by-play baseball game. And there are a number of firsts that came along with KDKA. For example, he not only did the first broadcast, he did the first baseball game. He did the first boxing match in 1921, April 11th. It was a 10-round bout between Johnny Ray and Johnny Dundee. He also called the first on-the-spot football game. It was Pitt against West Virginia. Now we call that the backyard brawl here when it happens. But back then, that backyard brawl was in 1921 on October 8th, and it was a Pitt victory. By the way, the first baseball game was a Pirate victory over the Philadelphia Phillies. It was 8-5 on August 5th, 1921. And in 1922, it was the first musical group that was established, the KDKA Little Symphony. And you can see some of the other firsts that are listed on this slide. We talked about AM stereo briefly in 1982, that KDKA became the first station to broadcast in AM stereo. And we can go on and on with the list here, but I think you get the idea. When you're an innovator, you have a lot of firsts. So I want to show the Rainbow Machine. This was a mobile broadcast unit that was all around in the 70s. In fact, I heard word and got a picture that that Rainbow Machine is currently located somewhere in Jamaica, but it still exists and is still out there. But I wanted to give you a nice colorful slide to look at, because it's at this point that I really want to talk about going back to before KDKA and who was responsible for wireless telegraphy. So let's talk about that for a moment here. We can go back in research, and I do want to give credit to a lot of the information that I've received in research has been from various sources over the time for preparing for this. One of which was a book that was written by Professor John Kittredge at Temple University, as well as Joe Baldino, who was at the time the president of the Broadcast Pioneers Education Fund. And there's really, really good recap of what was going on in the history of radio and wireless telegraphy that was written by Brian Bellinger, who's at the Radio Television Museum outside of Washington, D.C. And he does the Journal of National Capital, the Journal for the National Capital Radio and Television Museum outside of Washington, D.C. I think that's in Bowie, Maryland. So a lot of this information was culled from many, many sources. So let's just kind of go through a quick timeline right now and talk about a little bit about radio telegraphy. As you know, originally, it was just Morse code was the content that was delivered. When Marconi started with ship-to-shore communication, that communication was simply through Morse code. But Nathan Stubblefield, back in 1892, was able to transmit voice from a small shack located in Murray, Kentucky. Now, most of this was ground contour, so it didn't get out very far, but he at least was able to figure out to transmit voice over wireless. Then, of course, the one that we probably all know from your history books as far as doing voice over the air was Reginald Fesserman, who actually worked for Edison at a time. But Fesserman decided he wanted to test the radio telegraphy, and it was in Massachusetts. He was located up in his hometown of Brant Rock, Massachusetts, and he was trying to send the signal about 11 miles away to Plymouth, Massachusetts, which he did, and he was able to take care of that in December of 1906. Now, what he would do would send out, and he publicized that he was going to do a Christmas Eve show and a New Year's Eve show in which he played, I believe he himself played violin and sang. He played Handel's Messiah. He had a little short Christmas program that was heard on ships, they said, as far away as Norfolk, Virginia when he tried this. But Fesserman and his tests in Massachusetts never were done on a regular basis. So now we have to move into Leo DeForest, who was quite a character. He was more of a marketing guy out of, initially anyway, he became a transmitter constructor, but at that time he was more of a marketing guy. And he had his own station in New York City called 2XG. And as a publicity stunt, he decided to broadcast a performance of the Metropolitan Opera. But he didn't do it on a regular basis. But he was testing out the communications and crystal sets and who could hear him and see him and hear what he was doing. There were reports that he also had election returns on his 2XG in New York in 1916. So the 1916 election returns would have been on there. But again, nothing was ever done on a regular basis to be able to say that they were the first continuous broadcast operations. Now, there is an argument for out west in San Jose, California, for Charles Harold. Charles had a radio club. Actually, it was more of a vocational school to try and teach people about this upcoming wireless technology and telegraphy. Now, originally, he was doing it with Morse code, but what he would do at night is he figured out how to do with Fesserman's idea of doing the alternator transmitter. They were able to use a carbon microphone and then put music and voice on the wireless transmission. And Harold might be one of the ones to have the first continuous broadcast or regularly scheduled broadcast, because what he was doing was playing records in the evening to his students. He'd go home, fire up his transmitter, send out the music, and kids, while they were studying and listening to it, would listen to the music over what was licensed as FN, which eventually became KQW, which eventually became KCBS. So then we go to Wisconsin and the University of Wisconsin, where Professor Edward Burnell of the University of Wisconsin, he was initially doing Morse code to send weather reports to the farmers and to the ships that were in the Great Lakes region. He started doing this in 1915. In fact, he even had a 5 kilowatt transmitter that he was using on 9XM. So the students now were suddenly getting involved in radio telegraphy and understanding it, and they were teaching it at the University of Wisconsin. But then what happened was April 7th, 1917, the federal government shut down all wireless transmission to everyone except Frank Conrad in Pittsburgh, who with 8XK was experimenting and doing help with the Army and the Navy for communications with troops during World War I. And also the University of Wisconsin was able to continue their research to help out the Navy. But what they focused on at that point, when they were even able to transmit, was they were responsible for focusing on training wireless operators for the Navy. So they didn't so much worry about expanding or doing regular programming. They were focused on training Navy wireless transmitters, wireless operators. So as you can see, the timeline on all of this is pretty murky. I mean, we've gone through the research to try to say who's first, who's right, who's best. But then the one that comes up all the time that we talk about is 8MK out of Detroit, which started originally, they say, started doing regular programming about 5 weeks before they say that KDKA did. Well, there are no official records as to who started broadcasting on a regular basis first. The only official records through all of this research I was able to find out that was scanned by the National Association of Broadcasters, I think this was back in like 1947 or so, and these are the summaries that followed. 1916 is when KDKA was when 8XK was licensed as a new special land station to Frank Conrad. WWJ's origination was 8MK, but it's not listed at all in the Bureau of Navigation lists. 1917 to 19, World War I happens. All amateurs off the air. 1921 is when 8CS is first listed as licensed to WJ Scripps Detroit. Now, In 1920, to go over to the KDKA side, May 1st, 1920, 8XK is licensed as a new special land station to Frank Conrad in Pittsburgh. On November 1st, 1921, WBL is listed as a new commercial land station for Detroit, owned partially by the Detroit News. KDKA gets its license on November 1st. April 1st, 1922, the announcement of WWL.
You got 5 minutes, Jim.
Thank you. I want to talk about following up on what Mike had to say on studio locations. Of course, our first one was in Wilkinsburg for Frank Conrad. Our next one, East Pittsburgh. Hold on a second, I have to get a screen off of here. As we talked about 8ZZ coming in, and these are some of the studio locations of our KDKA in history. How about this? The Fort Pitt Hotel Bridal Suite for 2 months in 1929 is where our studios were located at. Then we moved to the Hotel William Penn for 5 years, and that was an exquisite location to have all sorts of great programming originating from. Then they moved to the Grant Building in 34 before they got this new tower in Allison Park, and then One Gateway Center. So those are some of the locations of the studios. Now, to follow up on what Mike had to say, these are some experimentations that were being done with a weather balloon to put the KDKA signal through lines, put it up in the air to try to measure to see how far out the signal would go, the precursor to the modern steel tower. So let's look at those towers. That first one, as Mike had mentioned before, the second tower from the 1994 to the present, the first tower 1939 to 94. And it's funny because I have here, and I'll show you a little bit later, that very acrylic of the tower from 1939 to 1994. Saxonburg, we talked about that with Mike. I won't get into details on that, but you can see the first location of the KDKA tower was at Frank Conrad's garage in 1916. Some other quick notes on KDKA's history. Do you realize that in 85 years, KDKA has only had 6 morning show hosts? Started with Ed Shaughnessy in 1935. Reach Cordick came in 1954. Art Palin and Bob Trode did 1965 to 68. Then the great legendary Jack Bogut came in from Montana in 1968, followed by John Cigna, who did the mornings from 83 to 2001, to our current day, Larry Richard, who is now currently the morning host at KDKA, which is pretty remarkable when you think about the fact that in 85 years, we've only had 6 morning show hosts. That handsome gentleman on the right, you may not recognize, but when he worked at KDKA, he actually went on to the NBC networks. And when he was at NBC, he ended up being the first host of the Today Show. That is Dave Garroway, ladies and gentlemen. So now where we're at after 100 years, we've celebrated our 100th anniversary on November 2nd. To celebrate that, we put an FM transponder on 100.1 to get on the FM dial as well. We've had a number of vignettes and interviews and special programs that you can listen to on our kdkaradio.com on the history of the station and some of the history of our talent as well. Obviously, COVID has forced us to cancel any kind of public displays. I mean, I was looking forward to wearing a tuxedo and going to celebrate all of the greatness that our radio station and our industry is, because this is not just a celebration of KDK, it's the celebration and the 100th anniversary of radio. So we continue to be the voice of Pittsburgh and look to contribute to our community and help out in any way we can to make our community great. There's just a summary of some of the things that we have talked about, and I really thank you for the opportunity to share a little bit of history on KDKA and on wireless telegraphy. And with that, I'll turn it back over to Tim. Thank you from all of us at KDKA.
Thank you, Jim. Fascinating presentation, really, really good. We're going to put the Q&A together for you and Chris Hudak at the end of Chris's talk. So Chris, are you ready to go?
Yep, we're ready to go here. I just need to get my video. Somebody's blocking my video sharing, so.
It should be available now.
Okay, let me try it again. Okay, let's take this from the top. Apologize for the, you know how electronics can be. Who knows?
There we go. We see your screen.
Okay. All right. I'll take it from the top. Good afternoon again, and thank you for inviting me. The talk today will be a little continuation of some of the operational and maintenance challenges that we faced at KDKA with use of the complex Franklin-style antennas. And we'll explore some of the new challenges that were brought on by the new implementation of the modified Franklin as it was retrofitted by Moffett, Lawson, and Johnson in 1994. KDKA is known as a broadcast facility operating with a power level of 50 kilowatts on 1020 kilohertz and has been providing a continuous service to the area since 1920. KDKA is always focused on the collinear antennas, otherwise known as the Franklin, namely named after Charles Franklin in the 30s, primarily for its high gain and low skywave reflection. But due to propagational characteristics pretty predominant on the AM medium wave band, however, KDKA has always struggled with high angle wave suppression and self-fading within its service area. Once FM radio started gaining a foothold in the late 70s and 80s, KDKA under the Westinghouse ownership spent many dollars and countless years of research trying to mitigate that self-fading problem and introduce an improvement to the listening experience. And you take a look at this photo here. The existing Franklin that had been in operation offered us a pretty good skywave suppression. However, the new modified design, we picked up another 7 to almost 10 dB of vertical skywave suppression that's very useful at night. And this quest to improve this self-fading was probably the driving force that led Westinghouse to decide to just scrap out the old design and give this new fangled modified design a go. And I'll try to address some of those other questions at the end of the seminar from that were asked of Mike, and we'll talk a little bit more in depth about it. This particular modified design was first presented in a paper by Ogden Prestolt while he was working at A.D. Ring and Associates. And Mike pointed in his presentation, the idea was implemented in 1995. The tower was reconstructed, and once complete, it was time to start up some of the initial testing and earlier experiments to see how well this thing would work. Well, what looked great on paper suddenly became quite cantankerous of an operation once full power was applied to this antenna. And some of the immediate issues that Mike pointed out, they experienced darking at the tuning unit and elsewhere along the structure. And at the time, I wasn't really sure where this stuff was occurring. So numerous transmitter trip-offs were occurring, and sometimes as many as could be as 100 a day, according to the old station records. And this eventually forced the station personnel to lower the SWR sensitivity to keep the old transmitters stable and on the air. And some of the initial thoughts of these were possible flashovers occurring at the guy wire insulators. So high impedance bleed-off resistors were installed and strapped across all the Johnny balls on the guy insulators. And this sort of settled it down in the high wind conditions and in cases where static electricity was mounting on the tower rapidly, and it was tough to dissipate it, even though the structure overall was technically grounded. And back in the day, number one on the hit parade was listener complaints. So you can imagine the management wasn't too happy about their situation. So for the next 18 years, some of the operational costs were quite expensive, as you can see by this photo. This was just one of numerous burnouts that we had experienced on the antenna tuning unit, which now had been located 270 feet above the ground and difficult for serviceability. So as time went on, we suffered several of these failures. I'll show you some other slides here. the extensive damage that would take place, and partly brought on by the fact that number one, they had a blowtorch for a transmitter. The old tube transmitters would drive practically a dead short, and further coupled by the fact that they lowered the SWR sensitivity to try to minimize the trip-off times. So that's a lesson for everyone. Never cheat interlocks and don't disable the safety protection. But here's the inside of the cabinet. And in quite a few instances, they just scrapped the entire cabinetry and started with a new cabinet. But we started drilling down into some other failures also, brought on by the high impedance at this feed point. By offsetting that feed point, we took a 300 ohm antenna from a balanced condition and now offset this thing sort of like a Windham in the amateur, popular amateur antenna. And therefore the impedance went crazy, and we were dealing with a feed point impedance of 1,000 ohms and 1,000 J. So the motorized tuning mechanism that you see here in the picture, that rod that's in the center of the coil is connected to the opposite, to the ground potential of the coil, and it drives the, I call it the skipper wheel that is adjusting the impedance. Well, what happens is, since that rod is at an opposite potential, we are seeing cases here, which I've highlighted, where the arcing would occur from that center rod straight over to the high side of the antenna. It could be touched off by a lightning event or something along those lines, but in some cases, it just would set itself off for unknown reasons. And this is another photo of the arcing that took place clean to the roof. So the original clearance was maybe 10 to 12 inches of clearance from the top of that high side of the coil to the roof of the tuning cabinet, which, keep in mind, is sitting at the opposite potential of the tower. So technically it's at RF ground. And if you look closely, you'll see a lot of evidence of pitting, and where it looked almost like somebody took a stun gun and just rapid fired that entire roof of the cabinet. So if you could have just imagined what's going on here during one of these events, the whole tuning box probably turned into a Van de Graaff generator of some sort. Here's some details on the coil failures themselves. And over the years, we've had at least 3 or 4 replacement coils in place, and started questioning some of the dielectric losses that were occurring there, especially it's a fiberglass material similar to a G10, but a little stronger. And again, with the impedance being 1,000 ohms and 1,000 J at 50 kilowatts, unmodulated, we've got about 85,000 volts sitting there. And with modulation on top of that, especially with the newer digital modulated transmitters, we're approaching 200 kV at times. So I started to conduct a little experiment on my own after one of these failures. I took a chunk of this material home with me and popped it in the old microwave oven, just as a little test to see just what kind of loss I would see. And within about a minute, I couldn't even touch that material. So after having some discussions with the manufacturer of this coil assembly, we later zoomed in on another type of dielectric material that seemed to hold up a lot better. And again, once some of these failures were occurring, and as Mike pointed out in his presentation, frequent climbing of the tower and trying to sort things out up there, the tower crew started noticing some structural damage occurring in areas of the tower. And keep in mind, this is a erected stick tower, as opposed to what was used in the early days. They had a complete welded tower with solid rod. So this angled tower is started to appear to be, you know, and the lack of the uniformity due to the fact that it wasn't welded together created some other problems, and severe ones at that. So we started investigating both that damage and also some of the other sections, these sleeved quarter wave matching sections that were comprised of the tower lighting conduit. So they sort of did double duty. They carried the tower lighting up the length of the tower, and also as a support structure for all the transmission line and sampling lines. However, they had 11 junction boxes inserted in series with all this galvanized conduit. And we started to see a lot of failure, in losing this RF ground created a major problem in operation. So the antenna would literally lose its RF integrity and flash over. And that's probably partly the result of why some of those bolts were just starting to flash over. And so it went on for quite a while, and around 2007, 2008, we were strapping the bypass, trying to bypass with a Band-Aid approach, if you will, copper straps and also cabling. We were using some cabling to try to strap around disjointed connections and improve all that. But it just got to the point where, and as Mike again pointed out, some consultants had decided that possibly some of the flashovers were occurring due to the fact that the insulators might have been undersized. So we beefed up all the insulators supporting that bazooka section and the entire length of the tower. However, the arcovers continued, and it seemed like we were just moving the problem. It's kind of like a leaky water pipe. You'd tighten it up here and something else would pop loose somewhere else. So the insulators were a good step in the right direction. So after years and years of this, in 2012, the management of the station decided, you know, what are we going to do with this thing? It's really costly to operate, and they decided to take on a program to see what we could do to either there were also thoughts about tearing it to the ground again and coming up with something else, or we took a deep dive on this whole thing and decided that we would replace all the bolts, weld all the members together, and create uniformity that way from an RF standpoint, and also address those bazooka sections by welding them all together also. But like any other remodeling project starts, and they usually end up this way, once you start peeling into the covers, and we found out that the upper sections of the bazooka sections were just raining rust and literally deteriorating on the inside. And this is an example. This photo shows the amount of rust just pouring down from the inside of that conduit. So we made the decision that we would not be able to weld any of that. So I gave the go-ahead to tear all that stuff down. It was 720 feet of conduit and the lighting boxes and the complete lighting system off the tower. And once we had it on the ground, you take a look at a couple of these, we could see where the unions and the coupling, possibly during the initial install, some of these threaded joints weren't brought together well enough. And, you know, over time, the corrosion, and then the fact that we've got dissimilar metals in play here. In addition, the RF path, despite, you know, this is one of the examples where we had a strap across this, you can still see evidence where maybe a lightning shot or something, or RF tried to seek ground, seek continuity, and it literally etched itself a path in this aluminum cover plate for that junction box. So all that said, we decided to replace everything and started peeling apart those sections. Once they sawed them down and brought them down, we started noticing that this might have been some of the root cause of some of the flashovers in the top section of the tower. This is a picture of the lighting wiring, and the neutral and some of the hot leads completely burned off the insulation due to the heating effect. So we're thinking that as time went on and we'd have an arc over or some sort of a meltdown up inside the bazooka section, that would literally dead short the top section of the tower. So all of a sudden you've got all this energy at the feed point going nowhere, and that produced all the corona discharges and you know, Van de Graaff effect that I spoke about earlier. So we replaced all that with 720 foot of 2-inch diameter, 3-inch wall stainless steel pipe. And I found out real quick in a hurry, you just can't order that and pick it up at Gray Bar in a local electric supply. So we had to special order it. And I can still remember the look on the GM's eyes. It was like dollar signs in his eyeballs when he saw the amount of pipe stacked up and the cost of this stuff. But I thought we would just finally replace it once and for all. And then as part of the welding process, we took the approach that we would strap out all of the JB boxes, and we also eliminated, I think originally the design had 11 lighting boxes in the circuit. We minimized those down to about 4 or 5 through the use of some messenger cabling dropped down as you know, as a pool inside the conduit, and made special attention to eliminate the junction points in the high current areas in the lower section of the tower, and also in the high current section of the at the half wave point. And here's another photo of where the brackets all tied into the gussets on the tower. You can see we welded all joints and all members on that tower, and also addressed the feed point. The original feed point, we were driving one leg with a sort of a bubble gum type weld that came down from the, you know, to the feed point on both the upper and lower sections. So the tower crew designed a yoke assembly made out of stainless here, and we welded all the joints and brought all 3 legs in uniformity, and then brought that down. This is the feed strap now with a turn in it to help reduce lightning mitigation, and then that attaches to the bowl insulator. And one other additional improvement there, we also addressed the previously the grounding and bonding kits. Those of you that do some tower work with transmission lines, you know, they give you like a number 4 or maybe a number 6 tail that you're supposed to bond everything. So to take it a little bit further, we bonded studs, welded studs to this stainless every 10 feet or so. And then to get a little bit better integrity at RF, especially at 1 megahertz, we used copper strapping at about 1.5 inches, 1.25 wide. And I built these up and cut them and prepped them up for the tower crew. So that's how we improve the connectivity in the event that we would lose the discontinuity of the RF grounding of the bazooka section. Also, due to that coil arcing repeatedly with the motor drive mechanism, we hated to lose it, but we had, you know, in my tenure there, I replaced 2 or 3 of these coils in a short time. It seems like after we did all the welding and everything, and like I said earlier, the plumbing system, it just started spewing more leaks everywhere else. So we were still having an issue with the coil arcing over. So we went with this new tapered Q design by staggering the turns, and it's manually adjusted now, unfortunately, but you can see also that we've changed the material. We're using this construction grade extend type material on the L network, and that's held up quite well, except we did have another failure in 2018 where the upper section here just caught fire for some unknown reason. So we've just sawed it out of there and eliminated it. I'm finding that it seems like if you introduce any stray capacitance in the area of that coil, it was creating some problem for us. So we just eliminated it completely. And as you can see in this photo now, we've gained quite a bit of clearance now on the between the top of the coil and the top of the tuning box. But during that same period of time, we saw evidence of where the RF now was starting to heat up some of the fastening screws and hardware. The door hinges were fastened with pop rivets. So we ground down the door frame and got back to bare metal, and then added a substantial amount of bonding and grounding for all the doors, and also along the framework of the box, and NOAA locks to everything, and it's been holding up quite nicely. You can see the RF bonding here, another shot, and we also added a lot more screws, you know, the typical RF approach every so many inches. So we really added quite a few quite a few additional attachment points. And one other note on the tuning box itself, up there in the catwalk area, we saw evidence where corona, during some of these flashovers, the RF would actually just flash over from the railing, which again is at a ground potential as far as RF is concerned versus the upper feet of the tower. So we replaced some of the safety railing with this construction grade X-Ten material also, and that is held up quite nicely. I just had the tower inspected here this past fall, and we've now got about 3 years under our belt with minimal interruptions. And we did have one lighting problem that popped up, but all in all, operation is, I think we've tamed this monster. And back in the old heydays, they used to call KDKA the blowtorch. And some of those photos, as you can see, I think we lived up to that reputation.
You got 5 minutes, Chris.
Okay. The only problem that we ran into is after completing the construction, we went back out and started evaluating some of the field strengths of the station, and started to notice that we had some external influences starting to weigh into our signal coverage in the local area anyway. And it was Ron Rackley that kind of focused in on a couple of things. I was focused on mainly the structure itself of these high tension towers, and we found out that the power company had installed a safety catenary wire for grounding purposes at the very top of this thing. Well, lo and behold, as we looked a little deeper into this, the power company has about 100 of these towers that bisect the site from one substation to another, as shown here on this map, some of which are 3/10 of a mile from the site. So we started evaluating some of the field strengths from early days that we had in the records to some of the performance issues that we're facing these days. And you can see by some of these photos here, this is a half mile over time. The original green would back from the 70s from records that we found. And then some of the other ones from initial turn on in 95. And then also at a 1 mile difference. And you can see some evidence of the re-radiation. Now, we found that that seems to vary with temperature and also your seasonal adjustments from winter to summer with the ground conductivity and everything. So, and there's a 2 mile shot of what takes place at some times of the day throughout the seasonal period. And like I said, a cold morning in the winter versus a warm afternoon, you can actually see evidence where that re-radiation changes. And Ron's theory was that the ground is forming a capacitor and might be tuning those loops. So we were actively working with the power company to kind of come up with a way to mitigate that right before Ron's passing. But in summary, I'd say that the Franklin, a great antenna, highest gain on the band, however, way more costly than a simple vertical standing in the air. As I mentioned, high maintenance cost. And the offset feed system was a great idea, and it did move the current node on the tower. However, it may have created a lot of, by driving that input impedance up so high, it's created a lot of high Q issues. And we've kind of traced the bandwidth and the Q of the whole thing to those upper bazooka sections. So it's sort of a length diameter issue that we're facing with the steel. And maybe the only way to clean that up is to go back to the old Austin ring open circuit type transformers. So it makes future digital transmissions a little tough without some broadbanding techniques. And KDKA still struggles today to provide interference-free reception due to rising noise floor on the AM band. And I couldn't let this presentation pass without thanking especially Ron Rackley. Became a great friend and mentor throughout this entire ordeal, and was very insightful on some of the mitigations that we applied at the station. Thank you very much.
Chris, great presentation, and thanks very much for that. We're on this morning here with Chris Hudak and also Jim Graci. Both are employees at KDKA Radio 1020 in Pittsburgh. They're celebrating their 100-year centennial celebration here the whole month of November. And for those of you who are on that are not members of the Radio Club of America, we do have a special going on. You can join the RCA for 3 years for $150. Just go to radioclubofamerica.org and become a member of the oldest wireless club in the world, started in 1909. With that, please put your questions in the Q&A or in the chat. And also remember that we will be breaking for lunch here at 50 minutes past the hour, so in about 10 minutes. But until then, let's do some Q&A, and let's start with Dave Pasco. Dave, do you have a question for Chris or Jim?
Yeah, good morning, Tim, and great job, Chris and Jim. Excellent presentations. Got one here. What was the change in field strength measurements between the old and the new tower?
We actually found that the new tower, and as based on some of the field studies from 1995, in the immediate near field were at least equal, or in a lot of cases exceeded the original design. And that was one of the immediate things that I took on after we sort of stabilized the, the structural and RF integrity of the tower. So I immediately wanted to do some near field measurements, and through that is how we sort of encountered the re-radiation characteristics popping up on some of those old substation structures that were there. The tree line and everything around that site is such that, you see maybe one or two in the distance over there and you think, okay, well, there's some power lines over there. But after you start plotting this out, Duquesne Light and is, over the years had snuck these in on us, and it fell under, since the station is a non-directional operation, none of that was ever flagged in the FCC database. Normally under a directional situation, we would have been notified of any changes that were being impacting the signal in our area. Over.
So, Chris, one of the things you talked about was that, the idea was to minimize fading, but also get good gain. The antenna as it's configured today, what is the difference in gain versus like a 90-degree quarter wave monopole?
It's almost 7 dB over a standard quarter wave.
All right, yeah, that's quite a bit of gain, but boy, what a lot of work. Nathaniel, question.
Sure, Tim. So for Chris, one person asks, what is causing the rising noise floor in the AM band and the KDKA antenna interference?
Well, the commission, as a matter of fact, there was a notice of inquiry here back several years back. The commission asked, do we have a rising noise floor in medium wave and also the amateur bands? And there were quite a few comments. I think later maybe Jeff Mendenhall can comment on it. I know he was a participant, and we all put comments together. And KDKA took a program on to trust me, we were getting listener complaints in droves. Jim can attest to this. I mean, we were starting to log these things, and I started going out on a lot of these complaints and noticing that cable television decoder boxes that were in use by cable providers in the area, they were all using switching power supplies on these devices. And quite a few of our listeners would complain, and one of the first questions was, are you a cable TV subscriber? And the answer was always yes. So I went to a couple, in a case of, say, an apartment building where there were 200 tenants in this place, and I took a field meter, and the moment I entered that building, and I'm talking a field strength outdoors of maybe 10 millivolts. The moment I entered the threshold of that building, I was overpowered with the field meter by buzz. And we went to the complainant's condo, and she demonstrated this for us. None of the radios in her condo would function, but yet if I went outside her patio deck and crossed the threshold out into the open air outdoors, boom, we've got reception. So that's how we kind of zoomed in on switching power supplies, and had to actually put a note to the commission, and actually got some action against the Comcast cable company. And they were all using the same devices. They buy them from an outfit called Pace Electronics, and we just found that there was just such an influx of these offshore cheese power supplies that that seems to be one of the #1 noise floor does, along with some of the new lighting devices, LED bulbs, and again, but they're powered by switching power supplies.
Yeah, and electric vehicles recharging
Yes.
as well. And then they took the AM radios out of the electric vehicles just because there's so much noise.
Yep.
Dave, another question.
The early KDKA logo shows a horizontal antenna. Was that used?
Yes, it was. In the early days, in the 20s and 30s, the horizontal antennas were the antenna of choice in the day, inverted L's and all that, with a counterpoise underneath of them. And KDKA, up until the 70s, actually had a horizontal wire antenna deployed out there, and the insulators are still on site. Those of you that had an opportunity to take that tour back when the RCA group came through a few years back, the insulators from some of that are still hanging out on the back of the building. And they used that antenna for many, many years as a backup. And that goes way back to where you saw that Zeppelin in the experiments out at the old Saxonburg transmitter site. They were deciding on what worked best. They actually transmitted for a while to the local, noticed that the ground wave was much better on horizontal polarization, but again, the distance was hurting. So, you know, it's kind of like 40 meters. You know, you have a local antenna for ground wave, and then you have your, you know, what we would call a DX style antenna. So in answer to someone else's question a little bit earlier, KDKA, and Jim can attest to this, we're already getting a seasonal shift. QSL cards coming in from Sweden and Finland and all over the world. That's one drawback of that antenna in today's environment. We may be better serving our audience locally with some other style antenna now. I mean, the days of the 750 mile and beyond coverage are diminishing for AM. And, you know, I've got a banging signal in Sweden at 2 o'clock in the morning, but I'm having still trouble with grandma at 50 miles away from the station. Go ahead.
Very good.
Chris, I just got one from Germany yesterday. I had to forward to you as well. So
they're still coming in. I want to remind our participants and viewers that courtesy of ICOM America and DX Engineering, we'll be giving away 2 ICOM radios at the end of the awards banquet. But you got to be present. You got to be on Zoom to be available for the drawing. So it's at the end of the awards banquet later on this evening or the afternoon, depending upon where you are. Want to make sure that you stick around and be a part of the audience, because we'll have Ray Novak on with us and do that. Let's go to Nathaniel for another question.
Sure, Tim. So Charles, Whiskey Zero Charlie Bravo Kilo asks, what are the inspection intervals for the tower, and is there any electronic monitoring of the tower?
Okay, well, I can tell you during from 1995 through about 2015 or so, we could say that maintenance was frequent, and it was usually repairs of some sort or other, as I showed some of the burnouts and different things that were occurring. We've now reduced that pretty much yearly for tower lighting work, replacement bulbs, and we do a periodic inspection of the entire structure to make sure that number one, all these new improved welds are holding up. We haven't developed any another hot spots on the doors or any of the cabinetry up there on the tower. And also the insulators aren't cracked or anything. And we also inspect the guy wires. We do have a couple of broken insulators on the guy wires right at this moment. But again, it's just one of those projects that it's constant maintenance. So the towers of that height, this is 720 feet. And someone else mentioned earlier why we didn't try to put up a full-size Franklin, which would have been over 1,000 feet at KDK's frequency. So to keep FAA minimized and local zoning and everything, that's the reason they settled in on this 3/4 wave Franklin. Go ahead.
All right, very good. Thank you, Chris. Final question for Chris and Jim from Dave.
Yeah. Were the bolts in the RF failure slide removed as is through what had to be, I guess, larger holes or put back together?
We replaced, I forget how many bolts. There were literally canisters of these bolts. We replaced every bolt on that tower, and then welded all the joints in the ones, the elongation and erosion there wasn't, we did actually replace some of the strut members where there was heavier damage. And all that was done prior, and then we brought in another crew of certified welders that spent over a month welding that entire structure, top to bottom.
All right, very good. Thank you, Chris, and thank you, Jim. Great presentations, and we wish you continued success. Here's to the next 100 years of KDKA 1020, and very exciting to have you both on.